Okay, so we're going to talk about constructing basic graphs. Okay. Now the video that I've asked you to watch goes over this. So I'm not going to spend a lot of time on this. I'm going to go over it rather quickly, but we want to be sure we're doubly reinforced on how this is done. So I'm going to start with the graph of y equals 2 to the x. And if you remember, I'm not going to write it down, but you should remember, and you should probably have this written down in your notes someplace because it's fundamental. The domain, which is the set of x values for these functions, is a set of values -2, -1, -1/2, 0, 1/2, 1, and 2. All these functions can be graphed in such a way that you see the behavior of the function quite well based on these points. But the domain excludes values at which the exact value can't be expressed. Got to the edge of the board there. Let's move this over just a little. Can't be expressed exactly. That's the T, this is the L. Exactly is an integer or a rational number. The form P over Q for P and Q are integers. And integers are just like your counting numbers, 1, 2, 3, 4, 5, and so forth. The negatives of those numbers, as well as 0. 0 isn't a counting number, but of course, well, it's a number that we need to complete the set of integers. Okay, so that's the definition. So we start off with a table. Of course, your function here is y equals 2 to the x. Okay, well, what's 2 raised to the -2? Okay, now, we're not going to use a calculator to do this. You don't understand anything about the calculation by plugging it in to a calculator, and you don't apply the rules for exponents by plugging into a calculator. So I would like everybody to quickly tell me what 2 to the -2 is by putting it into chat If you're unsure of your result, go ahead and just do it through private chat so not everybody sees it. If you think you would be embarrassed by giving a wrong answer, and you'll see me make arithmetic mistakes all the time. Usually don't make mathematical mistakes, just the details of the arithmetic. But and that's carelessness. I'm too busy talking to think, whatever. So I've got 2 responses already. I should get responses very quickly if everybody has done and I'm getting responses very quickly. I think that's 5 or 6 already. Okay, not see. There's a new one, yeah. And maybe 1 or 2 more that I'd like to see. But those came in quickly, and that's very good. Very good that you're responding quickly and that you know the right answer because everybody's been right. Okay. 2 to the negative 2. What's 2 to the negative 2? Well, by the laws of exponents, that's 1 over 2 to the second power. And if you didn't do this step, you'd better get it into your head because you're going to have to justify it when you have a test. You're going to have to tell me why 2 to the negative 2 is 1/4. You can't just tell me it's 1/4 because your test, it's not proctored. There's nothing to prevent you from using a calculator. Okay? And most of this course is calculator free. So when I test you, I'm going to have to test you in such a way that you have to explain the things that you would maybe otherwise do on a calculator. So be prepared for that. You really need to know this. You just did and I think almost everybody did the exercise on exponents, did quite well with it. So that's very good, very good. Okay, so anyhow, this is what we get. Of course, 2 squared is 1/4. So now this is 1/4. This is 1/2 because 2 to the negative 1 is 1 over 2 to the 1, and 2 to the 1 is 2. Okay, tell me, what do we do with negative 1/2? Can you enter that? Anybody got an answer for that? Well, let's see. 2 to the negative 1/2 is 1 over 2 to the 1/2. 2 to the 1/2 is the square root of 2. What in the world is that? You can't figure that out. I can't figure that out. Although I know an algorithm that if I had infinite time, I could use, and if I didn't make a mistake, I would keep approaching the value more and more closely. I can construct the square root of 2 using a triangle. Just a right triangle with legs of 1 has a hypotenuse that's the square root of 2. That's a Pythagorean theorem. That's simple. I could construct a square root of 2, but I can't express it as a rational number. And if I can't express it as a rational number, I certainly can't express it as an exact decimal. So what are we going to do with negative 1/2? We exclude negative 1/2 from the domain of the basic function. This can't be written as a P over Q. And of course, the problem there is that we can't do the square root of 2 exactly. So this one is also going to be excluded. Okay, we exclude these from the domain. Okay, well, 0. Okay. Everybody through private chats, so people don't just imitate. I don't think anybody did that. So people don't just imitate what they see on the screen. So do this through private chat. Tell me what 2 to the 0 is. Got one already. Yep, yep. It's 3. I should get 9 of them quickly, or 10. Okay, well, almost everybody has responded. And almost everybody has responded correctly, but somebody told me 0. And that can't be, for a number of reasons. 2 to the 0 equals 1. And there are reasons. It's not just a rule somebody made up. The laws of exponents aren't consistent. And I'll just off to the side prove that. You'll agree that 2 to the 0, 2 to the second power times 2 to the 0 equals 2 raised to the 2 plus 0, right? That's one of the rules of exponents. Or arithmetic isn't consistent unless we have that rule. And hopefully you understand why this addition rule is the rule. I'll be asking you to explain that, so make sure you do. Okay, well, this says that two to the 2 plus 0 is just 2 to the second, which is 4. So 4 times 2 to the 0 equals 4. What do you multiply by 4 to get 4? Well, the only way that makes sense is if 2 to the 0 is 1. If 2 to the 0 was 0, then your conclusion would be that 4 times 0 equals 4. So 0 equals 4. That's not correct. Okay. There are reasons for these rules. You want to know the rules, but you want to know the reasons behind them because you're going to be asked. Okay. So there's a reason for that. Review your work on exponents. Make sure you understand it. That's one. And there's very good reason why you need to be able to do that. And it has to do with the shapes of some of these graphs, as you'll see. Okay, well, then you're going to get 2 here and you're going to get 4 here. And I'm sure everybody can do that quicker than I wrote it down. So there we have the values. And now we construct the graph. Okay, construct the graph. Okay. So here we have -2 and 2, that's 4. So on the same scale, 4 would be up here. So then here's -1 and here's 1, halfway between 2 and 0 and -2 and 0. Halfway between 0 and 4 is 2. The halfway point looks to be about here. Did I do that right? Yeah, it's not bad. Better than usual. Okay, then we got 1 here. Then we get 3 here, of course. Okay, well, we're going to have points for x equals 1/2. So where's 1/2? X equals 1/2 here and here. I'm not going to label that because things are going to get too cluttered. But it's clear that that's the 1/2 point. If you've ever looked at a ruler or measuring tape, you understand how these things are subdivided. So this would be 1/2 and this would be 1/4. Yeah, that 1/2 is a little high, but this will do for now. When you do this, you want to mark these as accurately as possible so you get the right shape. Okay. Now, when x is -2, your y value is 1/4. So here's -2, here's 1/4. Here's your point. When x is -1, we get 1/2. So that's going to give you the point here. Then we have this. Then at x equals 1/2. And actually, we didn't need x equals -1/2 and 1/2. I crossed those out, but I put them in there anyhow because you need them for most of your graphs. Okay, then 1, 2, and 2, 4. And there's our basic function. Now, the basic function can be written as a set of ordered pairs. It's the set consisting of the point -2, 1/4, -1, 1/2, 0, 1, 1, 2, and 2, 4. The domain of this basic function, and give me just a second here. I set these used boards down here on the floor. And every time I get over to the end of the board, they do their best to block me. They can't really trip me because there's no place to fall. Just fall into a piece of furniture here. Okay, sorry for the interruption, but now I can stand over here where I want to. Basic function is this. The domain is the set of numbers -2, -1, 0, 1, and 2. The range is the set of values, which would be one-fourth, 1/2, 1, 2, and 4. So the domain is here, -2, -1, 0, 1, 2. The range is here, 1/4, 1/2, 1, 2, and 4. The extended basic function, and we demonstrated how this happens. Extended basic function looks like this. Now notice that that extended basic function does include a value for x equals 1/2, doesn't it? And it includes a value for x equals -1/2. Now, based on the picture you have here, or if you're taking notes and you've actually drawn this picture, based on that, I want everybody to estimate what okay, I'm gonna write it down here. We need to estimate 2 to the 1/2. You can't calculate it exactly as a p over q or as a decimal number, but you can estimate it, and you can estimate it as a decimal number. You know, tell me about what you think that is and enter that privately. I'm going to give you just about 30 seconds. You ought to be able to eyeball it. And I don't expect you to come out with a great estimate because this isn't a great graph. But you ought to, you know, if you think it's 28, then you did something wrong. And I might want to, no, that's not an estimate. That's something you either got out of the calculator or memorized. Fix that. Okay. I got a four significant figure result. You can't estimate 4 significant figures from this graph. I don't, you know, I'm not getting on you personally, but that's not legitimate. Okay, now I've got a couple of legitimate estimates. When I say estimate, I don't mean go to your calculator. I don't mean use a good approximation. Incidentally, the number you gave me was a great approximation. Okay. It's an approximation everybody knew uh, when I was in high school, of course, when I was in high school, we all had to take our chisels and carve it into our cave walls because we were living in caves in those days. Okay, uh, getting some good responses. Okay, how do you estimate this? You have to know this. Okay, and this is not a difficult skill, although you might not be great at making estimates. But here it is on the graph. Here's 1/2. To find the value at x equals 1/2, you come up to this point. You find the point on the curve where x equals 1/2, and you project that over here. Now, when I do that, this distance is just a little shy of this distance. So I'm getting something just a little less than 1.5. And my estimate is probably closer to 1.5 than it is to 1.4. But 1.4 is an estimate that would be accurate to two significant figures, to one decimal place. Okay, so here my estimate is 1.5 based on this graph. But notice that my graph goes a little high through this point, and it's a little high through this point. Okay, now if I did these points accurately, then my graph is actually a little high here. And then I might refine my estimate to 1.4 if I'm confident in this point and this point, and if I'm confident that the curve should actually be a little lower. It's actually about 1.4. And then somebody gave me 1.414. I challenge anybody to graph this thing accurately enough that you can distinguish between 1.4 and 1.414. Estimate this down to the thousandth, and a thousandth of a unit here. A unit's about an inch, so that would be 1 mil, and that's about the thickness of the plastic in a garbage bag. And if you look at that edge on, it's almost not even there. Very tiny, 1/1000th of this distance. So that's not an estimate. And that's what I was talking about. Again, if you know that's the value of the square root of 2, then very good. But it's not an estimate. Thank you anyhow. Okay, so you understand what I mean by estimate. Okay, well, that's a construction of a basic graph. Now, I'm going to leave the rest of the constructions to you, but they're all constructed in this manner. You have the formula, you plug the numbers in here, and you don't do them in your calculator, you do them by hand. But then if you want to check it on your calculator, that's fine, because that gives you immediate feedback in case you made an error. But don't base your graph on your calculator, because again, when you're tested, if you're asked to construct a basic graph, and you almost certainly will be, or if you're asked to do a calculation, using exponents or whatever, fractions, reciprocals, complex fractions, you're going to have to be able to tell me how you did it. And you'll have some written work that asks you to do that. If you don't know, it's not going to wreck your grade if you give it an attempt and you're wrong, but it will end up having an influence on your grade if I tell you, sorry, that was a good attempt, but look at this. Think about this. Here's how it's really done, and you want to correct this, okay? You're going to want to do that, okay, because it's an important idea that's essential to understanding the whole picture. All right. Well, okay, that's what you need to know about basic graphs and estimates. Well, there's one more important idea, and that includes, that comes back to the meaning of division. So let's do this. Let's say we have 2 points on a graph. We've got a graph of some function, not one of our basic functions, but here it is. And we've got 2 points in this graph. Let's say this point and this point. Okay, now if I estimate the y value for this point, call this point 1, call this point 2. I'm going to call the y value here y2. And I'm not even interested in what, sorry, that's y1. This is the first point. I'll get it straight eventually. Okay, so here's y1. And of course, there's an x1. And there are many cases where we want to estimate x1. I'm tempted to go ahead and do an estimate and show you something else, but I'm going to restrain myself. Then I got 0.2, and it gives me y2. And what I want you to do, we don't have any scale on this graph. This is based on what you see. Can you estimate y2 divided by y1? Okay, give me your estimate. Could be to the nearest whole number, or it could be a rational number, a fraction. But I think what I want you to do is estimate it as a whole number, or if you don't think a whole number exactly gets it, give me a decimal, whole number or decimal. And just enter that privately, and I'll give you about 30 seconds. Got one. Good estimate. Not bad. That's good. That's good. They're coming in. I'm going to give you a few more seconds. I've got 3. I think there's 7 more of you that I would love to have estimates from so I can tell how you're doing. Depending on what I see, I determine what I'm going to say next, okay? So the more I see, the better I can expand my explanation if necessary. Well, I'm not seeing anymore, so I think I have to expand my explanation. How many of these does it take to make this? There's 1, 2, 3. If y2 was up here, assuming I did that right with my fingers and who knows, if y2 is up here, then y2 divided by y1 would be 3. If I do y1 here and here, then if it was here, that would be 2. In other words, this number here could be 2y1. This number here could be 3y1. Okay. So this number appears to be, I would say 2.7y1. Okay. I could subdivide this, get 2.5. Yeah, I'm thinking 2.7y1. So So I'd say y2 over y1 is about 2.7. Now the estimates I got, everybody who estimated it estimated 2.5 or 3. If it's really 2.7, if my estimate was accurate, you just, you're in one side of my estimate or another, and you were close. Those are excellent estimates. Okay. And if they're done by eyeball, that's great, because you weren't able to draw them, but you just eyeball this. How many of these does it take to make this? That's what division means. Division doesn't mean punch this into your calculator and this and hit the equal sign. Division or execute or whatever you're doing with your calculator. Okay. Division means how many of these does it take to make that? And that's really an essential idea, because without that, you'll never understand vertical asymptotes. If you don't understand vertical asymptotes, then there's an extremely high probability that, like most students at the end of this course, still can't answer good questions about vertical asymptotes, still don't really understand what's going on. Okay, so we're talking here now about division. We're addressing the meaning of division. And I didn't have the insight or the foresight to wash one of the narrow boards, but I do have this. Okay, so I can expand on this a little. Let's take another one. And let's not worry about a graph, because actually the ratio of two y values in a graph isn't particularly important in most applications, although sometimes it is. Okay, would you estimate y2 over y1? Write that as you can write it as a fraction or a decimal, but ultimately we want a decimal that you haven't calculated. But right now I'll take anything. Good. Good. Okay. I think this last estimate was probably y1 over y2. We want y2 over y1. What I saw was a good estimate of y1 over y2. Okay, I'm getting a lot of good estimates. Okay. Give you a little more time. There are a few people that haven't responded yet. Okay, let's see now. If this is y1, then you don't really have to do this, but it helps if I subdivide the interval from 0 up to y1 in half, I get something about here, don't I? Then if I subdivide that into two subintervals, well, that's going to be half of a half. That's a quarter, or 0.25 y1. And then this down here looks like a little less than a half of 0.25 y1. So half of 0.25 is 0.125. So y1's a little less than that. I'm thinking if this is 0.25 y1, this looks like it's maybe about 0.1 times y1. In other words, whatever this is half of it, this is a fourth of it, and down here would be an eighth of it, and an eighth is pretty close to a tenth, and a tenth is a pretty good estimate. Now, if you estimated 0.2, that'd be okay. Somebody estimated 0.01. I think you meant 0.1, because 0.01 would be a tenth of this, and it would be way down here, probably within the chalk line, okay? Just a little above the origin. So y2 over y1, approximately a tenth, and y1 over y2 would then be approximately 10. Okay, this divided by this, it takes 10 of these to make this. Unless I got 1, 2, 3, 4. Yeah. Now I think actually I have to fudge a little bit on my halving of this interval. It should be a little bit lower. I got an estimate here of 7.5, and that's where I said, well, I think maybe you estimated this over this rather than this divided by this, okay? And I think 7.5 is probably nails it a lot better than 0.1 if you were doing, or than 10 if you were doing this. But what we're after here is not total accuracy, it's ballpark accuracy. Now, if you thought it was 0.5, well, it's clearly not, because if it was 0.5, then y2 would have to be up here. It'd have to be 0.5 of this. Okay, so we want to work on, and estimates, you know, there are some estimates close to 0.5. I think I got 0.3 and 0.4. 0.3 is getting down into the ballpark, but clearly it's probably less than that. Question is, then, what fraction of this is this? That's what division means there. Okay. Okay, here's y2. And down here, real close to the x-axis, about as close as I can draw it without the width of the chalk line blurring things, I've got y1. So what do you think y2 over y1 is? Then go ahead and enter your estimates. Okay, I'm getting estimates all over the place, and a lot of them are pretty good. Some of them are backwards. Some of them are doing y1 over y2. But if you got y1 over y2, you can reverse that to get y2 over y1. Okay, I'm appreciating all these responses. Let's get everybody. I got interesting response here, 7 over 0. But that number is a little more than 0. And what would happen, what we're going to do is we're going to consider what happens if this number gets closer and closer to 0. Okay. Okay, any other responses? Okay, yeah, again, some pretty good responses here. A lot of responses are around 100. Okay, I have responses between 30 and 100, any of which are plausible. One way to see this estimate is to start doubling. Okay, so now you don't see the graph well enough to see that this is going to be the double. And I'm not sure where exactly where the point of this chalk is going to be. Let's see here, it's here, okay. So I'm thinking that this would be 2y1. And then if I double this, it's going to be up here. So that would be 4y1. And then if I double that, 4y1 and 4y1, maybe here, it gives me 8y1. Now, if I've got 8 of them, well, I can double that. That puts me here. It gives me 16y1. And then if I got 16 of them, I can double that, and now I've got 32 of them. And if I double that, that gets me up here. It gives me 64y1. Now, if I wanted to get 100y1, well, I could add 32y1 to 16y1. That would put me up about here, a little bit too high, but that would be 96y1. Okay? Now, if I made just little errors in these, it could well be that these numbers ought to be a little bit lower, and 100 is really a good estimate. And I consider 100 to be a very good estimate. Okay. I was thinking it might be a little less than 100, because 1 over 100 is kind of hard to do. Yeah, screen no bigger than this using chalk. Okay, well, that's good. And if you said 30, that's okay. You know, turns out to be a little more than that, I'm pretty sure. But I don't expect you to be an estimated expert. Yeah, I don't expect you to be an expert. I don't expect you to be an expert at making estimates, but ballpark. So I would say anything over 30 is not a bad estimate here. Now, the point of this is, well, what happens if we continue shrinking this? Okay, so what happens? I can't draw anything much closer to the x-axis here, but you've seen pictures where you'll take a small part of a picture and blow it up. Okay, so if I blow up this small region here, where I've got my graph, and let's say I blow this up so much that y1 is here, and then I do I read this as y1 hat. Y1 has a hat on it. Okay, now, can you just kind of visualize where this would be down here if this is how y1 and y1 hat are compared? Okay, it would be so close that you wouldn't be able to distinguish it from the chalk line that indicates the horizontal axis. And, you know, I've been talking about this. I'm afraid that the watermark on the video might obscure some of what I have here, but here it is. Okay, so what's this going to do to the ratio? Is y2 over y1 going to get bigger or smaller? Sorry, is y2 over y1 hat and I leave myself room for the hat, y1 hat approximately equal to what? Okay, I'm seeing an answer about the bigger or smaller. Okay, is it going to be bigger or smaller? So let's answer that first. I've got one answer. I've got an answer about, an attempt to estimate the thing. Okay. Yeah, good. Okay, got any more responses? Okay, good. Now let's sort this out. You're thinking, and that's the main thing I want. And a lot of your answers are correct as far as the bigger or smaller. Some of your numbers look pretty good. But how many of these does it take to make this? At least 10, right? You need at least 10 of these to build up to this one, and probably a little more. Now I could subdivide, but let's just say not writing that clearly enough. All right, that is 0.1. Okay, now the question is, we're trying to do y2 over y1 half. Does it take more y1 hats to make y2 than it takes y1s? Okay, we're assuming, we'll assume that it takes 100 y1s to make y2. Is it going to take more or fewer y1 hats? Well, it should be clear that y1 hat is a lot smaller. It's just going to take more of these. It's going to take 10 of these to just make up y1. So there's going to be 10 of these in this little interval from here to here. And if there are 10 of these in this, and there are 100 of these in this, they're going to be 1,000. Now you might not estimate 1,000, but 1,000 is a pretty reasonable estimate. So I'm just going to say y2 over y1 hats maybe 1,000. Okay, well, the whole idea of division is how many of the smaller number go into the bigger number? How many smaller number do you need to make the bigger number? And then if you're dividing the smaller by the bigger, it'll be the reciprocal of that. But we'll concentrate on how many of the smaller does it take to make the bigger. That's the easier thing to estimate. Okay, well, you've got about 4 more minutes. Not enough time to really do what I want to do, but we can at least talk about it because I want you to be thinking about this. It's very important for understanding the graphs of a couple of these functions. Yeah, 1/2. If x is 1/2, y is 1/4. One over 1/4 can be pictured as this. Here's 1. Here's 1/4. How many of these does it take to make this? So how many 1/4 does it take to make 1? Yeah, go ahead and enter some answers, but I'm going to continue. Okay, so I've got one answer. Actually, let me give you a couple of seconds. Everybody should be able to answer this very, very quickly. How many of these does it take to make this? Well, got some answers pretty quick. I'm not getting any right now. Maybe you're about brain dead because we've been at this an hour. Okay, but it takes 4 of them. 1, 2, 3, 4. Okay. And I wrote here y equals 1/4. This is x squared that equals 1/4. Okay, so here the answer is 4. So if x equals 1/2, y is 4. And you didn't actually do any arithmetic, you just subdivided. Okay, we're going to run over maybe 2 or 3 minutes, but we'll be done here very quickly. If x is 1/10, then x squared is 1/10 times 1/10, which is 1 over 100. How many x squared does it take to make 1? Well, we could draw that. Okay, down here will be 1 over 100. Up here will be 1. You picture that as how many of these does it take to make this? Okay. So 1 divided by 1 over 100 has to equal 100. Now what happens is this gets tinier and tinier. It takes more and more of these to make this. Okay. I'm going to draw a conclusion here and ask you to think about it. One-tenth is closer to 0 than 1/4. And it's lots closer to 0 than 1/4. Well, so And I've got lots here. I'm going to replace lots by very much closer. Okay, 1/10 is closer. 1/10 squared is very much closer, because 1/100 is way closer to 0 than 1/4, which would be like here. Okay, so here'd be your 1/4. Here's your 1/100, way closer to 0. So 1/110 squared is very much bigger than 1/1/4 squared. How much closer to 0 can we get? The answer is as close as we want, if we're not actually trying to draw the silly thing. Okay? How much bigger can 1/x squared get as x gets close to 0? Answer. As big as we want. Okay? And the result of this is that the graph of 1/x squared, which in our basic function looks like this, and like this over here, has x. So here's where x equals 1/2. So x squared is 1/4. If x is 1/10, which isn't all that much less than 1/2, then this graph is all the way up at 100 rather than just 4. And we can keep getting closer and closer, as close as we want. So our graph can get as big as we want as long as we get closer and closer to 0. And that gives rise to a vertical asymptote. So on this side, the graph ends up looking like this. It approaches the y-axis as close as we want, but it gets as high as we want it to get, and it never gets to the y-axis. Now that's a big deal. It's something we really need to understand in order to understand rational functions and a couple of other things.
Why?
I didn't understand that, but okay. That's pretty loud. Okay, very good. Glad for the enthusiastic response, whatever. And so that's going to be it for today. I'll email you about your assignment, but of course it's posted on your My Open Math page. And I'll have a little bit more that I want you to do. One of the things I want you to do is, now that I'm getting a little bit familiar with you and your work, I'd like to know who you are and what's going on in your life and stuff. You don't have to write me a biography, but write me a little introduction. What are your goals? What's happening? And give me your opinion of the course so far. And we'll go from there. I don't know if I mentioned it, but I will not be able to be here Tuesday. Have to take a family member out of town for a medical visit. It's going to be an all clear, but we got to get the all clear before this person can drive and stuff like that. And it's going to take all day to drive to Charlottesville, have the appointment, come back. And I'm the only one that can do this, do the driving. Might have the person drive back if they want to. Don't think they really enjoy driving the interstate, so maybe not. I find it relaxing, so I'm going to have a pretty good day on Tuesday. Maybe a little more than I want, but okay. Okay, well, anyhow, I won't see you Tuesday, but I will have a video for you on the things that are coming up in chapter 1. The first couple sections of chapter 1 don't give people much trouble, but those will be coming up, and I'll address them. Okay. Thank you for being here. Enjoyed seeing you. If you got something you want to talk about or chat about or whatever, you're welcome to stay around, but I'm going to stop the recording now to make sure